Looking at variation and problem solving, section 8.4. Okay, we're going to start with the basics, direct variation. So, direct variation states that y varies directly as x, or y is directly proportional to x, if there is a non-zero constant k, such that y is equal to k times x, or k is equal to y over x. Now, I'm going to focus mostly on the y equals k times x, just because it's usually easier to pick one particular type and work with that versus using both types. So, I'm only really going to use this, although you can take this and solve for k to get that k is equal to y over x. Now, k, what is k? K is called the constant of variation. Okay, it's the constant of variation. So a constant means just like that. It's going to be a constant value. For instance, the speed of light. The speed of light is a constant value. It doesn't vary. The force of gravity. Okay, the force of gravity is a constant term. So when you're talking about these things, k is going to be that constant of variation. In fact, all variation problems are going to have a constant in them. Okay, so anytime you are writing a problem with variation, you need to have that constant k in your problem. So when you think direct, think multiply. We are going to look at different types of variation, but when you hear direct, you should immediately think multiply. So I'm going to multiply by my constant. So setting these up, suppose that y varies directly as x. So this is our information to set up our equation. Y varies directly as x. So y is equal to k. Since it says it's varying, that means we need to have that k value. Directly means multiply. Okay, and then what am I multiplying by? X. This one happens to be exactly like the one before, but we can have different stuff here. Okay, we can have different things that it's going to vary directly to. We can have different letters up front. It just depends. But I have y equals k times x, times because it is direct. So once I'm here, they give us all this other information. Y is 5 when x is 30. Find the constant of variation, so they want us to find the k value, and the direct variation equation. We'll talk about that one in a second. So let's start with finding our constant of variation. So y is equal to 5 when x is equal to 30. Okay, so if I want to find my constant of variation, I just solve for k. So k times 30, opposite of multiply is divide, so we're going to divide both sides by 30. So I've got k is equal to 5 over 30. Well, that reduces. 5 and 30 reduces to 1/6, so k is equal to 1 over 6. So that is my constant of variation. And if you need to, go ahead and label that constant of variation. So when they're asking for the constant of variation, you're looking for x. Now here they also want the direct variation equation. Well, the direct variation equation, just plug back in your k, and just the k. Just plug in k. So when I wrote my equation in the beginning here, y is equal to k times x, I'm just going to replace my k value in there. Y is equal to 1/6 times x. Just the k. I don't put in y values or x values. What this is, this direct variation equation, let's write that down. Equation. So now I know my constant of variation, which means this is going to be the constant for this entire problem. Okay? Constant isn't going to change. But let's say they asked me when x is 2, what is y? Well, I could plug in 2 and I could get my y. If x is 60, what is y? Plug in 60, get my y. They could give me y values. If y is 7, what would be x? So that's what the point of writing the direct variation equation is. And in life, this is typically, if I'm going to use this for problem solving, that's what I would use it for, is I would want to find the relationship between two different amounts, okay, and then from there, write an equation that I could use to find other amounts. That's kind of the point of it. So here, m varies directly as x squared. So let's write that out as an equation. M varies, so I'm going to write m equals k. Directly means multiply. as x squared. So it's not just an x this time, it's an x squared. So m equals k times x squared. Now here there's a typo. This should say m is 6 when x is 6. So get rid of the 3 there. So m is 6 when x is 6. So plug that in. 6 is equal to k times 6 squared. Okay, m is equal to k times 6 squared. So then I've got 6 is equal to k times 36, and that's just squaring the 6. Divide both sides by 36. Okay, k is equal to 6 over 36 reduces again to 1/6. That is a cursive k, by the way, in case you were wondering. That is a cursive k. That's what all of those are. So you'll see me write cursive k's a lot. I'm used to writing cursive k's when I do math, so I apologize if I switch back and forth. I'll try not to do that much, but it will happen. So, alright, so k is equal to 1/6. This is totally a coincidence. They're not always going to be 1/6. It just so happens to be that way. Okay, so then write the direct variation equation. So if I want to write the direct variation equation, that means I need to take that k value, plug it back into my original. So m equals 1/6 x squared. Okay, this was an x squared, so my new one should be x squared. And that's all there is to that. Hit the pause button, give this one a shot. Shouldn't take you very long. Come back, see if you got the correct answer. Okay, we're going to do it here. Suppose that y varies directly as x. So y varies directly to x. If y is 20, when x is 4, if y is 20 when x is 4, find the constant of variation and the direct variation equation. Make sure you get both in there. Constant of variation and the direct variation equation. So divide both sides by 4. I get that 5 is equal to k. Constant of variation done. Direct variation equation, plug it back in. Y is equal to 5 times x. Direct variation equation, both done. And that's really about as hard as direct variation gets, okay? Direct variation is just multiplication. Now, inverse variation. Y varies inversely as x, or y is inversely proportional to x if there is a non-zero constant k such that y is equal to k divided by x, or k is equal to y times x. Again, I'm going to use this first form here because just to stay consistent, I'm going to be looking at the ones with y equals instead of the k equals. So y is equal to k over x. That is an inverse relationship. Okay, so inverse, think divide. Direct, you multiply. Inverse, you divide. Direct, you multiply. Inverse, you divide. Which hopefully makes sense because inverse, okay, dividing is the inverse operation of multiplication. So y is equal to k divided by x. K is still our constant of variation. That hasn't changed. Okay, it is super important that k must be on top. It doesn't actually matter which way these end up. I'm going to get the same answer either way, but k must be on top. So suppose that u varies inversely with w. So u varies, u equals k. Anytime you see that, u varies, u equals k. Inversely means divide. Okay, so I'm going to divide with what? W. U equals k over w. So then if u is 3 and w is 5, you just plug those in. Well, to get rid of the 5 on bottom, I multiply by 5. So times 5, I get 15 is equal to k. There is my constant of variation. K is 15. Now they want the inverse variation equation. Don't let the fact that it says the inverse variation equation confuse you. You're still just plugging your k value back in. So my inverse variation would be u is equal to 15 over w. Done. Inverse variation equation, variation constant. Okay, so same thing here. Example 4, the variables of x and y vary inversely. X and Y vary inversely. What is the inverse variation that relates the variables if X is equal to 4 and Y is equal to negative 3? Now here, they just use different language. Okay, the variables of X and Y may vary inversely. I still have inverse, which means I'm dividing. Okay, I have X and Y. So X is equal to K over Y. It doesn't actually matter if I put the Y on this side or this side. It's going to give me the same answer either way. Okay, I chose X and then Y for the simple fact that X was listed first and Y was listed second, so I did X equals K over Y. What is important that K must be on top. Okay, K must be on top. So, X is equal to K over Y. What is the inverse variation that relates the variables if X is 4 and Y is negative 3? Again, just a fancy way of saying, what's my equation? Okay, the inverse variation that relates. What's my equation? That's what I'm looking for. So first let's figure out what K is when X is 4 and Y is negative 3. 4 is equal to K over negative 3. Multiply by negative 3, both sides. So K is equal to negative 12. So this is my constant of variation. They didn't actually ask for this one this time, so I'm not going to circle it. Okay, I am going to plug into my variation equation. X is equal to negative 12 over Y. Here is my variation equation. So that's inverses. There's a your turn on the next page. I would highly suggest you hit that pause button. If you missed on block day, this is what we did. We did this this section, just this front page at the end of block day. So if all you missed was block day, you're done. You've got those notes. You should already have the other notes if you showed up on Friday. If not, or if you're just trying to get a nice little refresher before the test, which is a very smart idea, by the way, kudos to you, then you can keep on watching. So, your turn. Hopefully you've paused, you've tried this, you've come back, and now you're about to check to see if your answer is the same as my answer, and I hope it is. So, suppose that A varies inversely with B. A varies. A equals K. Inversely means divide with B. So divide by B. Okay, whatever it's with, that goes over here. So if A is 8 when B is 2, 8 is equal to K over 2, multiply by 2. That means that K must be 16 because those 2's cancel. Find the constant of variation, done. And the inverse variation equation, not done, got to plug it back in. A is equal to 16 over B. I highly suggest that you are very careful when you read problems. This is true of all problems in math ever in the entire world. Read them very carefully. Make sure you are actually answering the question asked. Don't just get the constant of variation and stop. Okay, this one says find the inverse variation equation. Later on they're going to ask other things and we'll get there. But later on they might ask you to find the variation equation and then tell them what B is when A is 7. Okay, there might be some extra steps to it, so make sure you're paying attention to what they're actually asking for. They wanted a constant of variation, got it. Inverse variation equation, got it. So we're done. Now joint variation. Okay, if the ratio of a variable y to the product of two or more variables in constant, I'm pretty sure that's supposed to say is constant. Okay, if the ratio is, let's fix that, is constant, then y varies jointly as or is jointly proportional to the other variables. If, here's our formula, y equals k x z. Okay, now here's a few important things. One, there can be multiple. They only show two here. K is my constant still. Okay, K is the constant variation still. These are my variables, x and z. I could have thrown in all kinds of them. So I could have said x and z and w and v, anything more than one. If it's k times one variable, that is going to be a direct variation. If there's multiple variables, Okay, so multiple variables, then it is going to be a joint variation. That's the difference. Otherwise, when you see joint, it means multiply. Okay, we're multiplying again. Again, let me restate that one more time. Direct variation is just y equals k times x. There is one variable on this side and one variable on this side. They might not necessarily be y and x, but there's one variable on the left, one variable on the right, and a k value. If it is a joint variation, that's a little different. It's going to have multiple variables on the k side. Alright, so multiple, more, two or more, that's super important. Two or more means joint variation. Alright, so let's look at some. Not too hard though. Suppose x varies jointly with y and z. Okay, x varies, and this is important, you need to go in order here. X varies means x equals k. Okay, that's what this thing should trigger for you. X varies, x equals k. Jointly means multiply. Okay? Jointly means multiply. X varies means x equals k times y and z. So y times z, that's all multiplied together. Okay? You're typically going to see it like this. K, y, z. Those mean the same thing. This means k times y times z. And then it's the exact same thing we've been doing. If x is 36... K is still there, y is 3, and z is 2. Notice it's all multiplication. So 36 is equal to k times 6 divided by 6. 36 divided by 6 is 6. So k is equal to 6. So there is my constant of variation. That was the first part they asked for. And the joint variation equation, again, they just want the equation, so plug it back in for k. X is equal to 6 times y times z. X is equal to 6yz. If you do zy, that's fine, it's multiplication. You can switch it up, it doesn't matter. Okay, 6yz, as long as x is over there on the left-hand side, because x varies with all that stuff. Okay, so same thing here. Suppose A varies. Okay, let's just stop there. A varies. A equals K. That's the A varies. Jointly means multiply. Okay, jointly means multiply. So times C squared and M. A is equal to K times C squared times M. If you need to put the times in there, go for it. You don't have to. Okay, K times C squared times M. Two different variables there. There could be 3. This is just 2. Alright, so and A is 12. C is 2. Be very careful here because that 2 is squared. And M is 9. Okay? So then we're going to find that K. Notice that it says find M when A is 15 and C is 3. Well, we can't do that. Okay, it says find M when A is 15 and C is 3. We cannot do this piece until I have my variation equation. Okay, so we're still going to have to find K. That's going to happen on every single problem. You're going to have to find K. Okay, I can tell you that right now. You're going to have to find K. Alright, so order of operations says square first, so 12 is equal to K times 2 squared is 4. 4 times 9 is 36. Divide by 36. K is equal to 1/3. 12 goes into 36 3 times. 12, 24, 36. Okay? Do not plug in this into your calculator and get a decimal and round it. Everything else will be wrong. Okay? Say that one more time. Do not plug 12 divided by 36 in your calculator and round the decimal. If you do a rounded decimal, everything else will be wrong because we need to use this constant value and we need it to be exact. This is exact. If you do 1.33, or 0.33 rather, that's not exact, or 0.66, that's not exact, okay? Do not do that. Do not plug it in and round it up. So, 1/3 is my K value. So now they want me to find M when A is equal to 15. So if I use my new, here's my variation equation, C squared M. Okay, so now I know my constant of variation. So now if I plug in A, and I use my 1/3 value, and I plug in the C, because they want to know when A is 15 and C is 3, what is my M? Well, now I can solve for M. I've got to stop spinning this thing, don't I? Okay, so let's finish this off. So I get 15 is equal to 1/3 times 9 times M. Well, 1/3 times 9, 15 is equal to 3M divided by 3. 5 is equal to M. Now, please keep in mind that you can put this in the calculator. I'm not saying you can't use your calculator at all. What I am saying is do not get a decimal and round. Okay, so you're going to need to use that fraction button that we taught you in order to make sure that you're getting exact answers. So M is equal to 5 should be my answer. They wanted me to find M when A was 15 and C is 3. That's what I did. I started by finding the constant of variation so that I could do my equation. I couldn't just skip and do this. Okay, and I'm sure this is what a lot of us are thinking. If I plug in A into here and C into here, well, I still have K and M. I can't solve unless I only have one variable to solve for. So I have to find K first so I can plug it in, so that now the only thing I'm missing is that M. Now I can solve for M. Okay, hit that pause button, go to the your turn, try it, see what you can do, come back, see if you got the right answer. So I'm going to do it here. A varies jointly with B and C. If A is 45, when B is 5 and C is 3, find the constant of variation and the joint variation equation. So 45 is equal to 15K, divide by 15, or K times 15, it's the same thing. Divide by 15, so K is going to be 3, okay, because 45 divided by 15 is 3. So K is 3, that's my constant of variation, that's the first part. Plug it back in, and that is my variation equation. That is my second part. Alright, so that's variation equations. That's joint variation equations. Now we've got to look at combined variation equations. Okay, combined variation equations. So, when you're talking about combined variation equations, what you're looking at is just a combination, obviously the word combined. You're looking at a combination of all of these things. Okay, so variation that involves combinations of direct, inverse, and joint. So that's the only three kind we have. Direct is multiply, inverse is divide, joint is also multiply, but multiplying more than one. Okay, suppose y is directly proportional to x squared and inversely proportional to z. Okay, so y is, let's go, y equals k. Directly means multiply, so multiply by x squared. Inversely proportional to z, k over z. Now there is something that I want to really note. I only have one k value. I am not going to have more than one k value, just the one single k value. Here's my direct part, k times x squared, okay? And here's my inverse part, k divided by z, but it is the same k value. That is super, super important. There's only one k per problem, and there should be a k in every single problem. So, y is equal to kx squared over z. Now, what do they want us to do with that? If y is 24 when x is 4 and z is 2, find the constant of variation and the variation equation. Here we go. So y is 24, so 24 is equal to k times x is 4 squared, and z is 2, so divided by 2. Solve all of that. So 24 is equal to exponents first, 16 over 2. Okay, lots of ways you can go from here. I'm going to go ahead and do 16 divided by 2 is 8, so 24 is equal to 8k. 16 divided by 2 is 8. I reduce that fraction. Divide by 8. K is equal to 3. Constant of variation. Okay, not so bad. And then plug it back in. Y is equal to 3x squared over z. Variation equation. Okay, y is equal to 3x squared over z. Variation equation. Directly proportional to x squared, inversely proportional to z. Okay? So, let's see if I've actually got another sheet here, because I seem to have lost one of my sheets. There we go. Last little page here. Example 8, suppose B is directly proportional to A and inversely proportional to C. Okay, suppose B is directly proportional to A and inversely proportional to C. So B is direct means times, so times A. Inverse means divide, so divide by C. Same sort of thing. When B is 10, C is 2, A is 4. Find the constant of variation, so solve for K. 4 divided by 2 is 2, so I get 10 is equal to 2K divided by 2. K is equal to 5. That was my cursive K, sorry about that again. K is equal to 5. So there's my constant of variation. They also want the variation equation. Plug that in. B is equal to 5A over C. Hopefully this is starting to kind of sink in, look pretty simple. I'm hoping this will be some nice easy little points for you on this particular test. Okay, so next one. These last three are application problems. It's the same thing, they're just going to throw in some extra words here. So, if you want to, I would suggest you try to do these application problems by yourself. Okay, it's nothing new, they're just going to call a bunch of names, they're going to throw in some extra information, dig out the proper information. I'm going to do them up here, you can do them with me, or you can try to jump ahead and do them and then come back. So, Hooke's law states that the distance a spring stretches is directly proportional to the weight attached to the spring. If a 40-pound weight attached to the spring stretches the spring 5 inches, find the distance that a 65-pound weight attached to the spring stretches the spring. Okay, so here's the thing. They don't give me variables. I have to set up my variables. Okay, that's the very first thing I'm going to have to look at is what are my variables going to be. So I have the distance a spring stretches is directly proportional to the weight attached to the spring. Okay, so that's going to be my 2. I've got distance, and I'll just call it D because that makes sense. And I've got weight. Okay, and I'm going to call that weight, or W, I'm sorry. D is distance, W is weight. Okay, so distance is directly proportional to the weight. Okay, so D is K, don't forget the K, times W. Just because we have words in here now doesn't mean we don't still need a constant. Okay, so D is equal to K times W. And then if a 40-pound weight attached to the spring stretches the spring 5 inches, find the distance that a 65-pound weight attached to the spring stretches the spring. No problem. First we have to figure out what this K is. Okay, K here is going to be the constant that's determined by the stretch of the spring itself. So, let's plug that stuff in. I've got a 40-pound weight, and it's going to stretch it 5 inches. So there's my distance and my weight. 5 is equal to K times 40. Solve for K. Divide by 40. So my K value is going to be 1 over 8. Okay, so 1/8 is my constant of variation. Constant of variation. That's going to be my K value. Now, find the distance that a 65-pound weight attached to the spring stretches the string. So, if I use this in my new equation, so 1/8 W. This is my variation equation now with my constant in it. So now they give me a new distance, or no, they give me a new weight, I'm sorry. Find the distance, that's what I'm looking for, at a 65 pound weight attached to spring stretches it. Okay? So my new distance is going to be 1/8 times 65. Okay, so D is 65 over 8, which is just, that's going to be an approximate number there. Now, when you get to the very, very end, you can do the decimal and round. 8.125 inches. But only at the very end. If it is your final answer, then you can get a decimal and round. Okay, no, not anytime sooner. Like, I can't do 1/8 and do a decimal and just round it. That won't work, because then everything after that will be off a little bit. Okay, especially when you're talking about science and physics and all that kind of stuff. You don't want to be off just a little bit. A little bit can be a big difference. Okay, so a little bit can turn out to be a very, very big difference. Hold on, my computer screen has locked here again. Okay, so at the very end, then I can round. Okay, get a decimal and round. So, let's look at another one. Boyle's law says that if the temperature stays the same, the pressure P of a gas is inversely proportional to the volume V. Okay, so P, they've given me this one, they give me pressure P, and they give me the volume V, so they give me my variables this time. So P is inversely, so K over V, inverse means divide, inversely proportional to the volume. If a cylinder in a steam engine has pressure of 960 kilopascals when the volume is 1.4 cubic meters, find the pressure when the volume increases to 2.5 cubic meters. And I'm pretty sure there's some of you saying, I wish I'd have known this for physics. So, here we go. Inversely proportional. If the steam engine has a pressure of 960 kilopascals, this is my pressure, so it's my P. So 960 is equal to K over, and that's when we have 1.4 cubic meters. Solve for K. Multiply times 1.4, 1.4. So K here is going to equal 1,344. So this is going to be my constant, okay? This is my constant of variation. So now, find the pressure, so we're looking for P, when the volume increases to 2.5 cubic meters. So now we got to use our new equation. Here's my new equation, 1344 over V. I want to find my new pressure when my new volume increases to 2.5 cubic meters. Okay, so 2.5 cubic meters. So now you're going to divide that out, 1344 divided by 2.5. I can round now because this is going to be this is my final answer. So pressure is 537, helps if I write the 3, 537.6 kilopascals. Kilopascals, if you prefer. I think I'm saying that wrong. Kilopascals. Okay, so 537.6 kilopascals. So that would be your new pressure. So if I increase the volume to 2.5, then I get a 537.6 kilopascals worth of pressure. And if you think logically about this, hopefully that makes sense. If I put the same amount of gas into a bigger container, obviously my pressure is going to be a little bit less, right? My pressure will decrease if I make my container bigger, okay? It's not quite so packed in there. So, last one here. The power P in watts of an electric circuit varies jointly. Jointly means what? Multiply. As the resistance R and the square of the current I. Square of the current I. Be very careful with the wording. Read them carefully. The square of the current I. So, the power P varies. So, P equals K. Jointly means multiply. As the resistance R and the square of the current. So, I is the current and we have to square the current. Power is equal to the constant times the resistance times the current squared. After that, it's a plug and chug. So 600 watt microwave draws a current of 5 amps. The resistance is 24 ohms. What is the resistance of a 200 watt refrigerator that draws a current of 2.5? So first we got to figure out what our constant is. So 600 watts, that's power. We don't know our constant yet. The resistance is 24 ohms, and the current is 5 amperes. So 5 amps. Okay, you're going to get some kind of big numbers here sometimes. So here, 600 is equal to K times 24 times 25. Notice the only thing I squared was the current, which was that 5. So 5 squared is 25. 24 times 25 just so happens to equal 600. Divide that thing by 600. Note that it's not 0. It is actually K is equal to 1. Okay, so K is equal to 1. So my constant of variation is 1. Plug that in. P is equal to 1 RI squared. Now there's probably a lot of you wondering from this very point right here, saying, I know that formula. Its power is equal to the resistance times the current squared. Well, that's why. It's because our constant here is just 1. It ends up going away anyways. You don't even need the 1 there, so I'm going to just get rid of it. P is equal to R times I squared. So if my new power is 200 watts, okay, and I'm drawing 2.5 amps, they want to know what is the resistance. So I'm looking for R 2.5 squared. Okay, so 2.5 squared is going to be 625. So 200 is equal to R times 625. Divide by 6.25, I'm sorry, being improper. Divide by 6.25 and I get that the resistance will be 32 ohms. Okay, so I'm going to get 32 ohms of resistance for a 200 watt refrigerator drawing 2.5 amps. And that would be the end of variation. The biggest part is remembering those 3. Direct is multiply, inverse is divide, joint is multiplying with just more of them. Okay? And that's all the variation there is, and that's actually the end of Unit 14. Great fun. Enjoy!